integrate this function using a trigonometric substitution. Now, why are we using a trig substitution instead of a straight u substitution? Because notice that this x is in the denominator here, and it's not up in the numerator. If it were up in the numerator, I could do a straight u substitution because my du here would be 50x dx. But that's not the case. So since it's locked in the denominator, I don't have a u substitution that I can use here. So we're going to match up the form, and we see that this is the correct form. We've got our variable squared minus a number squared. So in this case, though, my variable is going to be the 25x squared that we've got there. So since it's supposed to be a single item squared, we're going to make 5x equal to the a, which is the square root of what's sitting right here. So that would be 2 secant of theta. All right, now we're using the 5x because it's the square root of the 25x squared, and we're using the 2 because it's the square root of the 4. All right, so now when I calculate the dx, my 5 dx would be 2 derivative of secant of theta is secant of theta, tangent of theta, d theta. So I divide by 5 to get the dx by itself. And now we're ready to substitute in. So we'd have the integral of, that becomes the square root of 25x squared is 4 secant squared theta when I square this expression, both sides, minus 4. And then in the denominator here, I would have x, which my x would be, I've got to divide by 5 here. So I'd have 2/5 secant of theta. And then my dx, we're going to replace the dx with, right here, 2/5 secant of theta, tangent of theta, d theta. Now notice I have this 2/5 in the denominator here and a 2/5 in the numerator there, so we'll just cross those right out because they're going to cancel. Now over here I can factor this 4 out of the radical to simplify it, and so we're going to do that next. But before we continue, we need to worry about our bounds, because I want to be able to put my equal sign right here. But I can't say a definite integral is equal to an indefinite integral. I need to change the bounds over. So to change the bounds, we plug the 2/5 into this expression for x. So I would have 5 times 2/5 equals 2 secant of theta. Well, those cross off, divide by 2, we get 1 is equal to the secant of theta. So now we need to know where is secant of theta equal to 1, and that happens when theta is 0, right on the unit circle. So my new lower bound is a 0. Now we're going to do the same thing with the 4/5. So I have 5 times 4/5 equals 2 secant of theta. The 5's cross off, divide by 2, and we get 2 is secant of theta. We know where that happens. That happens when cosine is equal to a 1/2 value. So on our unit circle, that would be at pi over 3. So that's my new upper bound. All right, so now we're going to pull the 2 out of the square root from the square root of 4. So I'll bring it all the way on the outside, and I'd have 2 times the integral from 0 to pi over 3. That'll leave me with a secant squared theta minus 1. And then I have over secant of theta. And then a secant of theta, tangent of theta, d theta. And I notice that these secants cross off. All right, now let's go back to our Pythagorean identity. Sine squared of x plus cosine squared of x is equal to 1. So that's one of our trigonometric identities. So I need the secant in there. So to get the secant in there, I divide by cosine squared of x all the way across. So that would give me tangent squared of x plus 1 is equal to the secant squared of x. So equivalently, tangent squared of x is equal to secant squared of x minus 1. So I'm plugging that in right here, where we have the secant squared of x minus 1, I'm going to replace that with the square root of tangent squared of theta. Got to be careful to use the same variable there. All right, and then we still have this tangent of theta right here, d theta. So square root of something squared, they undo one another. And we have 0 to pi over 3, tangent of theta times tangent of theta, d theta, and that would make tangent squared of theta, d theta. So now the question is, how do I integrate tangent squared? But what we might remember is we just made an identity right over here. Tangent squared of x is equal to secant squared x minus 1. So I'll replace that in here. So 2 times 0 to pi over 3. Replace tangent squared of theta with secant squared of theta minus 1 because we have antiderivatives for that. The antiderivative of secant squared is tangent of theta minus the antiderivative of 1 is theta from 0 to pi over 3. So plug in and we get 2 times tangent of pi over 3 minus pi over 3 minus the tangent of 0 minus makes a plus 0. So now we need to figure out the tangent of pi over 3. So again, I'm going to my unit circle, and I'm saying that tangent is sine over cosine. So at pi over 3, that would be root 3 over 2 divided by a half. That'll make a root 3 minus pi over 3. Tangent of 0, that's 0. So our solution is just 2 times root 3 minus pi over 3.